Hello my dear civil and mechanical engineers, how are you all? What's up? कैसे हैं सब लोग? अपोने किमेना चेन यल्लावनारू तुवाड़ा कियाल ही. Can you guys properly hear me? आवाज आ रही मेरी? So myself Chandrasekhar welcoming you all to this wonderful series which is Old is Gold. Why it is called as Old is Gold series? Because in this series we are going to discuss the hand-picked gate PYQs from the early 90s which are relevant in today's scenario as well. So today's session is all about the fluid mechanics previous year gate question which had been asked in 90s. The recent past years PYQs, last 5 years, 10 years PYQs, everybody had solved. You may find on YouTube. We had also had a series for last 5 year PYQs for all the subjects, but nobody had given you the series or the sessions for the early 90s gate PYQs. So this is here. It will be going to help you a lot in developing your fundamentals, in developing your concept, in improving your concepts and making you more confident in your gate examination, because the difficulty level pattern of the gate examination is more or less same throughout. The only thing is the paper pattern has changed slightly. Like earlier there were no MSQs, there were no NATs, there were only MCQs, and before 90s or in early 90s there were questions which had been asked for 5 marks, there were questions which had been asked for 3 marks as well. So we will discuss all the important questions which can help you to improve your understanding for the subject in today's session. All right, so please settle down fast, sit back, relax and enjoy this wonderful session for the fluid mechanics part 1. Before I start, let me quickly introduce myself. My name is Chandrasekhar. I am mechanical engineering graduate from IIT Delhi. I graduated in 2006. I have also cleared engineering services examination which is conducted by UPSC. In 2009, I had worked in Steel Authority of India Limited for a couple of years, as well as I have worked in a private consulting firm for more than 2 years. So my total industry experience is more than 4 years, and the rest of my experience, which is close to 11 years, I have been into teaching, guiding the students who are preparing for various competitive examinations like GATE, ESE and other PSUs. And I am quite comfortable in these many subjects of mechanical engineering. Fluid mechanics is the subject which is common for mechanical and civil, and that is the reason this session is going to be important, beneficial for all the civil as well as mechanical aspirants who are going to appear for GATE 2024 examination. So once again, I welcome you all from the bottom of my heart to this wonderful session. Namaskar, Adab, Shubh Sandhya, good evening, Sat Sri Akal, Assalamu Alaikum, Wanakam. Please get yourself settled down. Keep your pen, notebook and calculator. Try to solve as many questions as possible on your own. And if you have any difficulty, at least develop the thought process. And if you find any difficulty, you can always connect with me through the comment section. Hi Rohan, good evening, welcome. Can you guys hear me properly? If you have anything to discuss, you can always connect with me through the mail ID, or you can join me on the Telegram, which is Mechanical by Chandrasekhar. The link is also there on the bottom of the screen, or you can scan the QR code to become part of my Telegram channel, because a lot of students are already part of my Telegram channel who are preparing for GATE 2024. If you join such a group where all are GATE aspirants, it will help you a lot in developing the positive mindset, in developing the enthusiasm, energy, and to crack your GATE examination. Hi MS, welcome, good evening. So shall we start? I hope you guys have already appeared for the last 2 mega mock test, subject-wise mock test. The third subject-wise mock test will be starting from 11th to 17th of November. You just have to register yourself. The link to register yourself is already there in the description box. And this is the entire schedule of our mega mock test, MMC. So there will be 4 subject-wise tests and the remaining will be full-length test. And based on your performance in the mock test, you can unlock our test series also for the discounted prices. Hi Anil, welcome, good evening. Everybody, those who are watching me live, please do respond through the comment section. Mark your presence, mark your enthusiasm, show your energy through the comment section. Shall we start? And one more important benefit out of this series, the subject which we are discussing here on YouTube, that is fluid mechanics, for the same subject on the same day, you will be getting the free quiz on our BYJU'S exam prep app. So you just have to download the BYJU'S app and you can get more number of questions, practice questions, having the difficulty level as same as your actual gate difficulty. So this quiz will be available just after the class, or it might have been available right away. So after the class, after the session, you can attempt this quiz to know your in-depth understanding about the subject. All right. So shall we start? Everybody, please give me thumbs up, show some love, affection, and do not forget to like and share this session to all your friends. Let me start with question number 1. Hi Maniket, welcome, good to see you. So I hope here the mix of students are there, mechanical as well as civil, right? All right. Chaliye, let us start with first question from the viscosity, very important property which was asked in GATE 19.9. The kinematic viscosity of air at 20 degrees Celsius is given as 1.6 into 10 to the power minus 5 meters square per second. What will be the kinematic viscosity at 70 degrees Celsius? If you know the answer, if you have solved this question, please share your answer and please give it a try. In the meanwhile, let me discuss the solution as well with you. So the viscosity of a gas depends on the molecular momentum transfer or molecular collision. Viscosity of a liquid depends on the cohesive force, whereas the viscosity of the gas depends on the molecular momentum transfer, right? And molecular momentum transfer depends on the molecular velocity. So viscosity is proportional to molecular momentum transfer, which is proportional to molecular velocity, and according to kinetic theory of gas, molecular velocity is proportional to T to the power 1 by 2, absolute temperature to the power 1 by 2. That is the dynamic viscosity. And the density of a gas is inversely proportional to temperature, right? So dynamic viscosity is proportional to T to the power 1 by 2 and the density of a gas is inversely proportional to temperature. So kinematic viscosity, which is dynamic viscosity per unit density, is proportional to T to the power 3 by 2. You will get T to the power 3 by 2, right? So this is the relation for kinematic viscosity of a gas with temperature, and T must be absolute temperature. T must be absolute temperature. If the question would have been about the dynamic viscosity, then you would use the relation T to the power 1 by 2. But if the question is from the kinematic viscosity, then you should use the relation kinematic viscosity of a gas is proportional to T to the power 3 by 2. So kinematic viscosity at 70 degrees Celsius upon kinematic viscosity at 20 degrees Celsius is equal to, can we say this is 70 plus 273, it should be in Kelvin. Absolute means Kelvin, temperature must be in Kelvin, upon 20 plus 273 to the power 3 by 2. 20 degrees Celsius kinematic viscosity is already given. You can find out the kinematic viscosity corresponding to 70 degrees Celsius. It will be around 2.02 into 10 to the power minus 5 meters square per second. Please check. It will be around 2.02 into 10 to the power minus 5. So the nearest option, that is why it is mentioned as approximately, the nearest option is 2.2 into 10 to the power minus 5 meter square per second. I hope it is clear to everyone. Yes or no? If you have any doubt, you can always let me know through the comment section. Let us move to the next question. This is very, very beautiful question. This is masterpiece. Shown below are 3 cylindrical gates which restrain water in a 2-dimensional channel. There is water here. There are 3 figures where there is a water. There is water here as well as there is water here. This is the free surface, this is the free surface. And in the third figure, the water is here only. Now we need to find out which gate will experience the maximum vertical component, the minimum vertical component, and the maximum horizontal component of hydrostatic force. Very, very beautiful, marvelous question. So let me discuss this question. I will add one more figure. Let me add one more figure. D. Now try to understand. The fluid is water. So let us talk about the horizontal component of hydrostatic force. How to calculate horizontal component of hydrostatic force? By taking the vertical projection. Let me assume the cylinder to be having the dimension L into D. Let us assume the cylinder to be having the dimension L into D. L is the length of the cylinder, D is the diameter of the cylinder. So if I ask you FH1, take the vertical projection of the cylinder. That vertical projection will be a rectangle of dimension D by L, and then rho g ax bar, apply rho g ax bar to the vertical projection. So FH1 will be equal to rho of water into G into area is D into L into x bar. X bar will be D by 2. Isn't it D by 2? This is FH1. For all the figures, FH1 will be same. For all the figure, FH1 which is acting in right hand side will be same. Now let us talk about FH2. Now FH2, we will start from the right hand side. Do you agree FH2 on this? FH2. Can we say FH2 will be equal to FH1? In figure number D, FH2 will be equal to FH1. And what is FH net? Net horizontal force is FH1 minus FH2. Agreed or not? FH net, FH1 minus FH2. So in the figure number D, FH net will be equal to 0. In figure number D, FH net will be equal to 0. Now similarly in figure number C, do you agree FH2 is equal to 0? So FH net is equal to FH1 only. Figure number C. If we talk about figure number B, this will be FH2. Take the vertical projection. So here FH2 is equal to rho of water into G into area will be D by 2 into L into x bar. This is the free surface. X bar is the depth of centroid of the vertical projection from the free surface. So it will be D by 4. FH2 will be D by 4. Now if you talk about figure number A, then this FH2, the projection will be same, but the free surface is here. This is the level of the free surface. So FH2 is rho of water into G into area of the projection is D by 2 into L. Area of the projection will be D by 2 into L. But if we talk about x bar, then it will be D by 2 plus D by 4. Do you get it? In figure number A, FH2 will be equal to D by 2 plus D by 4. Or we can say D by 4, isn't it? So if we write the decreasing order of FH net, do you guys agree with this? FH1 is same for all. FH1 will be same for all, and FH net is equal to FH1 minus FH2. So if we write the order of FH net, decreasing order, which will be having the maximum FH net, that is equal to C. C will be having maximum and D will be having minimum FH net. And out of A and B, FH2 is greater than FH2 in B, isn't it? So do you agree it will be B and then A? This will be the order C, B, A, D. C is maximum, then B, then A, and finally D. This is FH net. Similarly, if we talk about FE net, so FE net is nothing but buoyant force. This is the buoyant force. FE net is buoyant force. So if we calculate FE net, the vertical upward force, FE1 plus FE2, let me, if we start with first part this, let me call this as FE1. So this will be given by rho into G into V by 2. FE1 is equal to rho of water into G into volume by 2. Similarly, if we talk about second figure, FE1, that is this same. If we talk about figure number C, FE1, rho into G into V by 2. Because there is a downward force on the top, there is an upward force on the bottom. Similarly, figure number D, FE1, FE1 will be same in all the figures. Now, if we talk about FE2 in figure number D, so we can say FE2 is equal to FE1. And what is FE net? That is equal to FE1 plus FE2 because both are vertical. So FE net here will be equal to rho of water into G into V. That is FE net for figure number D. So FE2 is equal to 0 for C. So FE net is equal to rho into G into V by 2 only V1. If we talk about figure number B, rho into G, what is FE2? FE2 is equal to rho of water into G into V by 4. So FE net will be equal to rho of water into G into V by 2 plus V by 4, that is 3V by 4. Now if we talk about figure number A, that is most important. So weight of the fluid displaced by the body, the free surface is here. In figure number 1, the free surface is here. So what we need to do is, we need to find out the weight of the fluid which is displaced by the, this will be FE net, this is FE2. FE2 will be given by this. So here FE net is equal to rho of water into G into, it will be 3V by 4 plus it will be D by 2 into D by 2 into L. Other than 3V by 4, this portion will also be there. So D by 2 into D by 2 into L. So the maximum is in A. If we talk about FE net, maximum is in A. It is more than the volume of a cylinder. Then it is in D, equal to volume of the cylinder. Then it will be in B, 3/4 of volume of the cylinder. These are the buoyant force. And finally C, which is half of the volume of the cylinder. Do you agree? This is how FE net is. Hi Hari Sindhu, welcome, good evening. Do you guys understand it? This is the decreasing order. No two figures will have same FH or same FE. This is the buoyant force. This is the buoyant force. So if we solve this question, the maximum vertical component is in A. FE maximum is in A. The minimum vertical FE minimum will be in, minimum is in C, and FH maximum, who out of these which will have FH maximum? FH maximum will be in C. FH maximum will be in C. These will be the answer. These will be the answer. Do you understand? Is this all clear? Yes or no? Everybody please do write me in the comment section if it is all clear to everyone. This is wonderful question. Numerical can also be framed out of this. रोहन, D में वर्टिकल फोर्स मैक्सिमम नहीं होगा, हाँ सॉरी, वर्टिकल फोर्स मैक्सिमम होगा A में, वर्टिकल फोर्स A में मैक्सिमम होगा, मिनिमम होगा C में, हॉरिजॉन्टल मैक्सिमम C में होगा. The next question, this was asked in gate 96. A mercury manometer, there is a mercury manometer, this is mercury, is used to measure the static pressure at a point in a water pipeline. This is point A, let us say. Static pressure at a point in a water pipe as shown in figure. The level difference of mercury in 2 limbs is 10 mm. This is the difference in the level of mercury, 10 mm. This will be 10 mm. The gauge pressure at point A is, so the problem which many students faced was this distance is not given. This is not given. The dimension which is not given, we can assume it as 0, negligible. So if we assume it as 0, so we can say if this is PA, we can say this point will also have the pressure PA. So if we write the pressure equation, so this can be assumed as PA, then this will be the datum line. On this line the pressure will be equal. So from PA we are moving in downward directions, plus rho of water into G into 10 mm, 0.1, 0.01 meter, 0.01. Then we reached here, jump, then we are moving in upward direction, minus rho of mercury into G into 0.01 is equal to, here the gauge pressure will be 0. This is the pressure equation. Write the pressure equation, then PA will be equal to rho of mercury is 13,600 minus 1000 into G, that is 9.81 into 0.01 Pascal. What will be the answer? This is the gauge pressure at A. What will be the answer? Can you solve it and let me know the answer for this one? It will be option A. A option. Are you getting option A or not? Do you guys understand? The dimension, the distance which is not given in the question, you can assume it as 0. You can assume it as 0. Otherwise, you cannot solve. If the question says data insufficient, if one of the option is data insufficient, then you should select that. The next question which was asked in gate 88. A circular plate of 1 meter in diameter. There is a circular plate of diameter 1 meter is submerged vertically in water such that its upper edge is 8 meter below the surface of water. This distance is 8 meter. 8 meter. This is the free surface. The total hydrostatic force on one side of the plate is, can you solve it? This is the center of the plate and the depth of centroid of the plate from the free surface is x bar. Do you agree x bar is equal to 8.5 meter? So the force will be equal to rho of water into G into area into x bar. This will be the formula. So rho of water is 1000 into 9.81 into area is pi by 4 d square into 8.5. That will give you in Newton. So in kilonewton it will be 9.81 into pi into 8.5 divided by 4 kilonewton. That will be the force. It is simple. That will be the force. And the force is always acting at center of pressure. The force will be acting at center of pressure. Can you find out the depth of center of pressure as well? Can you find out the depth of CP, HCP? Do you know how to find out? Yes, B will be the correct answer. Well done guys, well done. Keep it up. Good, good, good. Can you find out the depth of CP? Very simple. Use the formula. HCP is equal to x bar, that is 8.5, plus IG, that is pi by 64 d to the power 4 upon area pi by 4 d square into x bar. If you will solve this, then you will get HCP, which is greater than 8.5 meter. You will get HCP greater than 8.5. You can solve it. X bar plus IG by x bar. IG will be equal to pi by 64 d to the power 4. Let us move to the next one. This question was asked in gate 90. The next one. The question says, read the question everybody. The question says, the cross-sectional area of one limb of a U2 manometer, which is shown in figure, is made 500 times larger than the other. So we can say A1 is equal to 500 times A2. This is A1, this is A2. It is a single column manometer. So that the pressure difference between the two limbs can be determined by measuring H only. In a single column manometer we can, yes, Rohan, that is correct. It is 8.507 something. Good. Determined by measuring H on one limb of the manometer. The percentage error involved is. So what is the percentage error? Error is equal to actual pressure minus measured pressure. That will be the error. So if we calculate, if we find out the actual pressure, look, if the pressure here is, let us say P is the pressure, and this was the initial level. It is having an initial level like this. This is the initial level, let us say. This is the initial level. When it is not connected, if both the limbs are open to atmosphere, this was the initial level. Whenever the P pressure is applied, then the level will slightly go down. This is the new level. The level will go down. Here the pressure is P, and there will be a rise in level in the right limb. So P actual, if we want to find out, then it will be is equal to rho of mercury. Is it mercury? Nothing is mentioned about the fluid. Rho into G into H plus delta H, isn't it? That is P actual. But if we ignore this delta H, because A1 is very large compared to A2, so delta H is very small. Delta H will be very small. So P measured will be simply rho G H. So error will be equal to rho into G into H plus delta H minus H. So it will be, error will be equal to rho into G into delta H. This is the error. Rho into G into delta H will be the error. And percentage error is error divided by measured pressure into 100 will be percentage error. So rho G delta H upon rho G H into 100. So rho G getting cancelled out. This will give you the percentage error. So how to find out delta H by H? How to find out delta H by H? So can we say the volume of manometric fluid always remains constant because we are neither adding any fluid, we are not removing. Volume of manometric fluid remains constant. So we can say the volume decreasing in the left limb, A1 delta H. A1 delta H is equal to volume rising in the right limb from the initial level. So A2 into H, and A1 is 500 times 500 A2 into delta H is equal to A2 into H. A2 getting cancelled out. So delta H by H into 100 is equal to 1 by 500 into 100. How much is that? That is 1 by 5. That is 0.2%. Percentage error will be equal to 0.2%. 0.2% will be the percentage error. I hope it is clear to all of you. Do you guys understand? There is an error in the measurement. C will be the answer. This was asked in gate 90. Anybody is having any doubt? Anything to ask? The next question is again beautiful, which was asked in gate 95. The force F, this is the force F which is needed to support the liquid of density D. The liquid is having a density D and the vessel on the top is. What will be the force required to hold the piston which is of area capital A, and there is a liquid in the vessel and the tube of the vessel is having the area small a. So there are two ways. Are you able to? Am I audible and visible or not? Can you guys hear me? Yes. So the force F needed to hold. What we can do is we can find out the pressure here. What will be the value of pressure here? One method is finding the pressure at this location. This is the free surface. At the free surface, pressure is P atm or gauge pressure will be 0. Gauge pressure will be 0. So the pressure is given by, because it is, this point is at a depth of capital H. So it is rho into or D into density is equal to D into G into capital H. That is the pressure, and the force will be equal to, the force required will be that equal to the downward force exerted B into G, or weight is rho into G into area into capital H. That is equal to F required. That will be equal to F required. So the correct answer is option B. B will be the right answer. मुझे लग रहा है थोड़ा नेटवर्क में इश्यू हो रहा है. Are you guys facing the issue in the network? I feel there is an issue with the network. आपको भी बफरिंग हो रहा है ना? So the correct answer is, the right answer is option B. The right answer is option B. B होगा, C नहीं होगा. That is called as hydrostatic paradox. I hope it is clear to everyone. I hope it is clear to everyone. So let us move further. Before that, there is an important announcement that we will be conducting the national level scholarship test for GATE examination, and the scholarship test will be on 11th and 12th. That is Saturday and Sunday, coming Saturday and Sunday. Due to Diwali on Sunday, the test is conducted on both the days. Any time between 9 AM to 9 PM you can appear for the test, and to register yourself, the link is already mentioned in the description box. Shall we continue further? Now, is it still buffering or it is fine? So do not get afraid of committing mistakes. अगर आप गलती भी कर रहे हैं तो at least you are learning something new, you are improving yourself, right? Shall we continue further? I hope you guys are enjoying. The next question, this was asked for 3 marks or 5 marks in GATE 98. Now it is fine now. A cylinder of mass 10 kg. This is again from the pressure. A cylinder of mass 10 kg and area of cross section 0.1. Area of cross section is 0.1 meter square. The mass of the cylinder is 10 kg. Is tied down with a string in the vessel containing 2 liquids as shown in figure. There are 2 liquids A and B. Calculate the gauge pressure on the cylinder bottom. Can you find out the gauge pressure here? Can you find out the gauge pressure at the bottom of the cylinder? And the tension in the string. 2 things we need to calculate. Gauge pressure at the bottom of the cylinder and tension in the string. Density of water is this. Specific gravity of A is 0.8. It means A is some oil having the density as 800. Specific gravity of B is 1. That is water. B is water only. So can you find out the gauge pressure? Everyone, do let me know the gauge pressure at the bottom. Free surface gauge pressure will be equal to 0. At the free surface, the gauge pressure will be 0. We are traveling in downward direction. We are traveling in A. So rho A into G into 0.1 is the pressure at the interface, plus rho of B into G into 0.125. That will be the pressure, gauge pressure at the bottom, PB gauge. This is the gauge pressure at the bottom. Can you find it out? Density of A is 800 into 0.1 plus 1000 into 0.125 into 9.81. What is the answer? What is the gauge pressure at the bottom B? Can you find out the gauge pressure at the bottom B? Are you getting 200? It is 2.01. How much you are getting? Are you getting 2011.05? Are you guys getting gauge pressure as 2011.05? Yes, 2.01 kilopascal. Well done. It will be 2.01 kilopascal. 2011. Right? Now, how to calculate the tension? So the force at the bottom will be the buoyant force due to pressure. That is called as buoyant force, upward direction. So buoyant force is equal to pressure into area. Area is 0.1. So buoyant force is equal to 201.105 Newton. And if we cut the string here, tension is acting in downward direction and weight of the cylinder is acting in the downward direction. So we can say weight plus tension is equal to buoyant force. So tension is equal to buoyant force minus weight. And what is the weight? Weight is equal to M into G. G is 9.81 and M is equal to 10 kg. So tension is equal to 201.105 minus 10 into 9.81. This will be in Newton. So tension in the string. How much is the tension in the string? Are you getting 103.005 Newton? 103. Are you getting tension as 103? Tension will be 103. The next one from the kinematics. A Newtonian fluid has the following velocity field. The rate of shear deformation epsilon yz at the point x is equal to -2, y is equal to -1 and z is equal to 2 for the given flow is. So if we equate it ui cap plus vj cap plus wk cap, what you are getting? U is equal to x square y, v is equal to 2xy square into z, and w is equal to minus yz cube. Are you getting this? And the rate of angular deformation in yz plane is equal to del y plus del z. Here it will be del w, here it will be del v. So it will be del w by del y. What is del w by del y? That is minus z cube plus del v by del z. Del v by del z is 2xy square. That is epsilon yz. Put the value, z is equal to 2. So minus, it will be 2 cube plus 2, x is equal to -2 and y square. What is y? Y is equal to -1 square. What will be the answer? Epsilon yz, what do you get? So it is -8. This will be again -4. So it will be -12 is the answer. -12 will be the answer. C will be the answer. C will be the answer. C hoga na, -8 -4. It will be -8 -4. C will be the correct answer. Are you getting it or not? Any doubt you are having, do let me know. The next question from the kinematics was asked in 89. The stream function in a two-dimensional flow field is given by this expression. The magnitude of velocity at point 1, 1. So we can say del psi by del y is equal to u, and minus of del psi by del x is equal to v. What is u? Del psi by del y? Isn't it minus 2y? What is v? V is equal to minus 2x. So at 1, 1, so u is equal to minus 2 and v is equal to at 1, 1, u is equal to minus 2, v is equal to minus 2. So the magnitude of velocity is equal to under root of u square plus v square, that is under root of minus 2 square plus minus 2 square. So it will be 4 plus 4 under root 16, under root of 16. What is under root 16? Sorry, under root of 8, not 16. It will be under root of 8. So isn't it 2 root 2? Isn't it 2 root 2? रोहन, डिफॉर्मेशन में हाफ नहीं आता है. रेट ऑफ एंगुलर डिफॉर्मेशन जो होता है एप्सिलॉन एक्स वाई इज इक्वल टू डेल वी. डिफॉर्मेशन में हाफ नहीं आता है बिकॉज rate of angular deformation is the total rate of change of angles of initially drawn perpendicular line segments. Total rate of change of angles for the initially drawn perpendicular line segments. अगर angular velocity होता तो half आता. Angular velocity चाहिए omega z, that is the angular velocity about z axis. Angular velocity में होता half into del v by del x minus del u by del y. दो difference आते. एंगुलर वेलोसिटी और रेट ऑफ एंगुलर डिफॉर्मेशन में ये दो चेंज है. वन इज दिस, अनदर इज दिस. यहां नहीं आएगा और यहां ये नहीं होगा. राइट? आर यू गेटिंग इट? रेट ऑफ एंगुलर डिफॉर्मेशन होता है टोटल रेट ऑफ चेंज ऑफ एंगल्स ऑफ इनिशियली ड्रॉन परपेंडिकुलर लाइन सेगमेंट्स. एंगुलर वेलोसिटी होता है द रेट ऑफ चेंज ऑफ द एवरेज ऑफ रेट ऑफ चेंज ऑफ एंगल्स ऑफ इनिशियली ड्रॉन परपेंडिकुलर लाइन सेगमेंट्स. एंगुलर वेलोसिटी इज अबाउट द एवरेज and angular deformation is about the total change. The next one, this was asked in 93. A velocity field is given by this expression. इसको कंपेयर कर लीजिए यू आई कैप प्लस वी जे कैप प्लस डब्ल्यू के कैप. ध्यान से कंपेयर करना. आई कैप की टर्म u इज इक्वल टू 3x स्क्वायर वाई, v is equal to 0, there is no component of j cap, and w is equal to minus 6xyz. Now we need to find out whether the flow is incompressible. To check whether the flow is incompressible, find out, use the continuity equation, del u by del x plus del v by del y plus del w by del z. Check this. What is the value? What is del u by del x? 6xy plus 0 plus what is del w by del z? Del w by del z is how much? Minus 6xy. So it is equal to 0. So that is RHS. So it is incompressible. The flow is incompressible. One is correct. Check whether it is rotational or irrotational. So for rotational, angular velocity about y-axis. What is angular velocity about y-axis? Half of del z minus del x. So it will be del u, it will be del w. Find out half of del u by del z, 0. Minus del w by del x, that is minus 6xy. It is not 0, so it is rotational. It is not 0, so it is rotational. So it is not rotation. Whether the flow is steady or not, do you see V is not a function of time? So it is steady flow. There is no time coordinate involved, so the flow is steady as well. Because there is no time coordinate involved, so the flow is steady as well. So 1 and 3 will be the answer. 1 and 3. The next one, the velocity component in x and y direction are given by this u and v. The value of lambda for a possible flow field involving an incompressible fluid. You need to do del u by del x plus del v by del y is equal to 0. That is the continuity equation. You will find the value of lambda. That is the continuity equation for incompressible flow. The similar type of question. You can solve it. The option will be D. D will be the answer. If you solve this, then you will get option D. Find out del u by del x, find out del v by del y, add them and put 0. You will get the value of lambda. You will get the value of lambda. 3 will be the answer. Now some questions from the dynamics. Tomorrow we will be discussing the questions from dynamics, fluid dynamics, but couple of questions let us have a discussion about. In a hand operated liquid sphere like a perfume or deodorant, hand operated liquid spray like a perfume or a deodorant, figure shown in the figure is shown. The liquid from the container rises to the top of the tube because of what will be the answer? How the liquid rises to the top? What is the answer? What will be the answer for this? How the liquid in the container will rise? Due to movement of the piston, when the piston movement, air velocity will increase, and due to Bernoulli principle the pressure will decrease. Here the suction will be created. Here the suction will be created, pressure will decrease, and due to decrease in pressure, due to vacuum pressure, suction or vacuum is created, and due to this vacuum the fluid rises to the top. The fluid will rise to the top. It is not due to capillary effect, due to suction produced by the air jet at the top end of the tube. B will be the answer. That is how the hand operated sprays works. The next one, shown in the figure are 3 pipe sections through which water flows. This was asked in 93. Yes, there are 3 pipe sections, pipe 1, pipe 2 and pipe 3. Option A to D below pertain to the direction of the net force on the pipe. The direction of the force on the pipe section due to flow of water. State which of the option indicate the correct direction of force for pipe 1, pipe 2 and pipe 3. There will be different options for different pipe. Can you find out? For pipe 1, what will be the direction of force? For pipe 1, what will be the direction of force? This is the question from the momentum equation, but the momentum equation is not required. It is only about the direction of force. Whenever there is a bend in a pipe, there will be force developed on the pipe as well as on the fluid, and according to Newton's third law, for every action there is an equal and opposite reaction. Look, if we talk about pipe 1, this is the bend section. This will be the bend. If I show you this bend, so the fluid will exert a force. The water will be exerting a force which is normal and compressive. The water will be exerting a force which is normal and compressive on the bend like this. Because of less area at the inner walls and because the less pressure, inner walls will have lesser pressure, outer walls will have more pressure. So Pi is less than P naught and area AI is less than A naught. So outer walls will experience more force, inner walls will experience less force. So the force will be having in this, the direction of force F on the pipe will be like this. So it is 45 degree to negative x and 45 degree to positive y, isn't it? It is 45 degree to negative x and 45 degree to positive y. 45 degree to negative x and 45 degree to positive y. So this is B on the pipe. If the question would have been about the water, so force on water would have been like this. Force on water. Force on the water would have been like this. Opposite. Similarly for pipe 2, can you find out for pipe 2? This is the bend section. This is how the bend will look like in second case. The fluid will exert a force which is normal and compressive. Inner walls will experience less pressure. Outer walls will experience more pressure. Inner walls will experience less pressure and outer walls will experience more pressure. So the net force will be like this. This is 45 degree to positive x and 45 degree to negative y, isn't it? This is force on the pipe. So 45 degree to positive x and 45 degree to negative y. This is C. And if the force would have been on the water, force on water would have been opposite to this. And similarly the third case, this is the bend. This is the bend portion. Inner walls will experience less force because of less area, less pressure. Outer walls will experience more force. Pressure force is always normal and compressive. So the net force on the pipe will be like this. Pipe. So it will be 45 degree to negative x and 45 degree to negative y. So for figure number C, 45 degree to negative x and 45 degree to negative y. D will be the answer. For pipe 1, B, for pipe 2, C, and for pipe D, pipe 3rd, C, D. B, C, D will be the answer. Do you understand? B, C, D. Yes. Well done, Rohan. Do you guys understand? If the question would have been to find out the force on the water, then your direction would have been different. Force on water would have been like this. In third case, the force on water would have been like this. This is the direction of force on water. But the question is force on the pipe. The question is force on the pipe. The question is about the force on the pipe. I hope this is clear. Now, can you solve this one? Can you find out the answer to this one? This is simple. '87 it was asked. A mercury manometer is attached to a section of the pipe shown in the figure. The flow is from right to left. Mercury levels are indicated when there is no water flowing in the pipe. The level of mercury is same when there is no water flowing because the pressure is same. When the water starts flowing through the pipe continuously at constant rate in the direction of the arrow, then the level of mercury at B will rise, will fall, or will remain same. Will rise, will fall, or will there be no change? Can you let me know? Mercury level. This is point B, let us say this is point A. This is, let us say, 1 or 2. So when the fluid is flowing from 1 to 2, when the fluid is flowing from 1 to 2, the fluid is flowing from 1 to 2, what is happening? The area is increasing, isn't it? Area will increase from 1 to 2. It is diverging section. If area is increasing because of constant discharge, velocity will decrease, and because of energy conservation, pressure will increase. This is the Bernoulli principle or energy, and this is about the mass. Because of mass conservation or continuity equation, if there is an increase in area, velocity will decrease and pressure will increase. So can we say P1 will be less than P2? P1 will be at point 1 the pressure will be less, at point 2 pressure will be more. So if P1 is less, then the level will rise, isn't it? P2 is more, the level will fall. Do you get it? So at point B the level will rise. At B the level will rise. I hope this is clear. The next question, this is the inverted manometer. This is inverted manometer. I will share the PDF of this session to my Telegram channel, and do not forget to attempt the quiz also available on the BYJU'S app. If you are not having the BYJU'S app installed, do install the BYJU'S app through the Play Store, or the link is already there in the description box. Go through the description box once. So this is inverted manometer. It is actually inverted manometer attached to the pitot tube. So the question is to find out the velocity V. So velocity V is equal to CV into under root of 2gx. X is this manometric fluid deflection. Then it will be 1 minus SM by SF, because it is inverted manometer. CV is not given, so we can take it as 1. 2 into 9.81 into X. X is 0.3 into 1 minus specific gravity of manometric fluid. The density of manometric fluid should be less than density of the flowing fluid in case of inverted manometer. 1 minus 0.8, the flowing fluid is water, that is 1. That will give you the answer. What is the answer? Meter per second. Are you getting 1.085 meter per second or not? Are you getting it or not? 1.085. नहीं 1.085 आएगा रोहन. You should get 1.085, right? So more questions we will discuss in tomorrow's session. Let me give you couple of assignment questions. Tomorrow we will discuss these questions. This is your assignment question. This is your another assignment. These are two assignment questions. Please try to solve this question at home. I will share the PDF also. And this is all from my side. Tomorrow at 9 p.m. I will be taking the fluid mechanics part 2. Alright. The dynamics will be discussed tomorrow. Couple of questions I have discussed from the dynamics today, but the remaining part. And you can use this bit.ly link to download the BYJU'S exam prep app. It is already there in the description box, and it is in all my sessions, all my YouTube sessions, it is there. This bit.ly link is there in the description box. So that is all from my side, guys. Please do not forget to like and share this session to all your friends, colleagues, civil engineering friends as well. Those who have not participated, they can participate in tomorrow's session. And we are running couple of courses, one for GATE 2024 aspirants, that is the crash course, and for 2025 and 2026 aspirants also we are running long-term batches. So if you are interested, or if anybody in your known is interested, you can ask them to call the counselor and get more details about this. So that is all from my side. You can join me on the Telegram. I will share the PDF of this session to my Telegram channel. So thank you very much, guys. Thank you for your active involvement, active participation. I hope you guys have enjoyed it. I thoroughly enjoyed the session. So see you tomorrow at 9 for the part 2. Till then, enjoy, take care, have a good night. Shubh Ratri, Sabba Khair, and Jai Hind. Thank you very much once again.